We're going to continue solving quadratic equations. We saw how to solve them using factoring and how to solve them using the square root property in the last video. In this video, we're going to look at solving them using completing the square. So that is our third method for solving quadratic equations. If you are given x squared plus bx, then you can add b over 2 squared to that expression to get a perfect square trinomial that looks like this. The value of that is that it always factors into this form. And so the b that we're talking about here is this guy. So we're going to do a couple of examples where we just find that term and then see how it works. And then we'll talk about how we use that to actually solve equations. Here we have x squared plus 4x. So our b is 4 here. If you notice, what we're looking for is b over 2 squared. So we're going to take that 4, divide it by 2, and then square that number. Well, 4 divided by 2 is 2. When you square that, you get 4. It says what terms should be added to each binomial to complete the square of the following. So that is the answer to this question. 4 is what should be added. Let me show you the benefit of that. If we add 4 to that, the benefit is that that is equal to x plus 2 times x plus 2. If you factor that, you see you're looking for some two numbers that multiply to give you 4, that add up to 4, which is this perfect square trinomial x plus 2 quantity squared when you put it in its factored form. Okay? One thing I want you to note is that this 2 right here is the b over 2, this guy, before you square it. Okay? One other thing that's really important. These not equal to each other, right? We added 4 to this one, so we have changed that. That's going to be an important thing when we start solving these. Let's go ahead and look at another example here. One thing we have to be a little careful of in our box up here, it says if you're given x squared plus bx. Well, we don't have x squared here. We have 2x squared minus 3x. So I am going to factor out a 2 here so that I do have, inside the parentheses at least, just the x squared plus bx. And now my b is negative 3/2. When I divide that by 2 and square it, it's probably easiest in this case with a fraction to remember that dividing by 2 is the same thing as multiplying by 1/2. So that becomes negative 3/4 squared, right? If you multiply by 1/2, you have negative 3/2 times 1/2, and you multiply straight across. That's the negative 3/4. Okay, when we square that, we get 9/16. That's what we would add to just the x squared minus 3/2 x to get that perfect square trinomial inside that parentheses. And that factors into x minus 3/4 quantity squared. Again, noting that that negative 3/4, sometimes it's harder to see how that factors when you've got fractions in there, but it's always going to be what's inside here that goes there. Okay, it's the b over 2. Again, this is not equivalent to what we started with because we added this 9/16 inside the parentheses there. okay? But it does help us see that we can get to a nicer looking thing. Let's see how we use this to solve equations. Erase just a little bit here so we can see that a little bit better. X squared minus 8x plus 9 equal to 0. It's a quadratic equation, right? So we have our possible methods. The first thing I would try if I saw this was factoring. Because with the 9, I'm thinking, ooh, maybe like negative 9 and 1, but that's not going to give me positive 9. So, shoot, this doesn't factor because what multiplies to give you positive 9? 9 and 1, 3 and 3, or the negatives of both of those would give you positive 9 as a product. Neither of those would add up to negative 8. So that means that we can't use factoring. We have to try something different. Square root property doesn't really work as it is right now because I've got that x term. Here's how we do it completing the square. Subtract 9 from both sides of this equation. I left a little space here because I'm going to do some work in there. I'm actually going to complete the square on that x squared minus 8x. My b is the negative 8, it's that number in front of the x. Divide it by 2 and square it. When I divide it by 2, I get negative 4. Squaring that is 16. That means we are going to add 16 here. But I can't just add 16 to that side of the equation. That changes the equation, which means it changes the solutions. An equation is like a scale, right? It's balanced. We have to balance it. So we are going to add it to both sides of the equation to keep it balanced. The left-hand side of this is that perfect square trinomial that factors into x minus 4 quantity squared. The right side is 7. We can now use the square root property since we have a quantity squared. Okay? That allows us to simplify that into x minus 4 equals plus or minus the square root of 7. It's a little messy. Let me get rid of that. Try that again. Plus or minus. There we go. And then we add 4 to both sides. We get 4 plus or minus root 7. If you prefer, you can write that as x equals 4 plus the square root of 7. X equals 4 minus the square root of 7. Okay? So we got two solutions there. So that worked. All right, let's take a look at another example here. We are going to start this using the same techniques. We are going to add 1 to both sides. I always leave myself a little bit of space to work in there when I'm using completing the square. This might factor. We'd have to work at it a little bit. It doesn't look like it just from a quick glance. These are a little bit harder to factor when that coefficient in front of the x squared isn't 1, but we could work on it. This one, I can tell by looking at it, just a quick look that it's not going to factor. Even if it did, the directions tell us to complete the square, so we're going to do that. I need to have a 1 in front of my x squared. So I factored out a 2 here. To complete the square on it, I need to just have x squared there. No other coefficient other than 1. Now I'm going to take the b that I have on what's inside the parentheses, which is negative 2, divide it by 2, and square it. That gives me positive 1. I am going to add 1 here to complete that square. On the right-hand side of the equation, I can't just add 1 I have to add 2. I have to keep it balanced. So you may be asking yourself, why did we add 2 on the right side and 1 on the left side? The answer is we did not just add 1 on the left side. Because of the 2 that is in front here, if you think about if we distributed that and had no parentheses on the left-hand side, we would have it's actually 2 that's the net gain on that side of the equation. So now we have 2 times x squared. Oops, where's that? We're going to factor that. Go ahead and factor that. That is x minus 1 quantity squared, and I have 3 on the right side. Remember, when I complete the square, what I'm ultimately doing is trying to use that square root property. So I need to get whatever I have squared by itself. In this case, the x minus 1 quantity is what is squared. So I am going to divide both sides of this equation by 2. Now we square root both sides and still use our plus minus using our square root property. X minus 1 is equal to plus or minus the square root of 3/2. Add 1 to both sides, you get x equals 1 plus or minus the square root of 3/2. If you want to rationalize the denominator, you can multiply just this guy by root 2 over root 2. You're just multiplying by 1, so you can do it to just that part of it. And that becomes 1 plus or minus the square root of 6 over 2. More commonly, this would be seen with a common denominator. So we would write it as 2 plus or minus the square root of 6 over 2. In essence, just multiplying this by 2 over 2 to get the same denominator as I have on that radical. So that would be your 2 solutions to this equation. So that is how we solve an equation using completing the square. So there are 2 different levels of difficulty there. Be very careful with this idea of what you're adding as a net gain to both sides of the equation. Make sure those match. Okay. I'm going to wrap this video up here. We'll come back and I'll do a last video using the quadratic equation to solve some of these equations. The quadratic formula to solve some of these quadratic equations. And then we will look at some applications as well.